Today's lesson is going to focus on the difference between observation and inference. It's a little bit tricky because it's almost like unlearning the way we think. Ever since we were little, we've been learning new information, adding it to our mind, and using it to help us make decisions about new things we see. At some point in your life, you learned what a chair looks like. Now, even when you see different kinds of chairs, different colors, different shapes, you still recognize them as chairs. It's something that you've learned and something that you've learned to recognize in the world around you. When you think like a scientist, sometimes you have to ignore the things that you've already learned and instead look at exactly what you're seeing. Today we will practice this skill. We'll look exactly at what we see and observe in a picture. We'll talk about ways to observe those things, and we'll try not to let our thoughts and expectations get in the way. Observations. Observations are made with the 5 senses. Tell what you see, hear, feel, taste, or smell. Do not allow your prior knowledge to interfere with or add to your observation. For example, if you were making observations of this picture of a baby, you might say, "It's a small child. It has blue or green eyes, it has reddish blonde hair, its mouth is open in an O shape, and its hand is on its chin." However, you may not observe that the baby is surprised. That is an inference. You may guess that the child is surprised based on previous experiences, but you do not know for sure. Your observations may not include guesses at what is happening. The same is true in chemistry. When observing reactions that take place on the atomic or molecular level, you cannot see what is actually happening with your bare eyes. Making objective, qualitative, and quantitative observations will ensure that you accurately represent what happens in a reaction. Do not guess what you think is happening. Instead, tell us exactly what you see. For example, when watching the experiment taking place in this picture, you might observe that the large beaker contains nearly 200 milliliters of liquid, and the Erlenmeyer flask just 100 milliliters. The liquids are clear in daylight, but show up a bright blue in darkness, like in this picture. However, you may not observe that the liquid glows in the dark. It may seem correct, but it is an inference based on your previous experience. It is not an objective, scientific observation. You don't really know what's happening. In this particular case, for instance, if you had observed that the liquid glowed in the dark, you would have been wrong. Rather, the reaction itself is producing and releasing light. This emission of light, along with the limited emission of heat, is part of a process called chemiluminescence, and it's the result of a chemical reaction. Now let's practice these skills. From your teacher, or from our website, download the worksheet called Footprints. First, we'll do a practice. At the top of your sheet are listed a few observations. Number 1, I hear people screaming. Number 2, I see many people. Number 3, I smell cotton candy, popcorn, and hamburgers. Pause this video, and at the top of your sheet in the box that says Inference, write what you would infer is happening based on your observations. Alright, let's move on. You're about to see a picture broken into 3 frames. I'll show you the first part, then add a second part, and then finally show you the whole picture. As I open up each frame, pause this video and write down 3 observations and then make an inference of what you think is happening. Go ahead and repeat for frames 2 and frames 3. Here's the first frame. Press pause. Alright, if you're ready, here's frame number 2. Press pause if you need more time. If you're ready, here's frame number 3. Press pause again if you need more time. Did your inferences change over time? Did seeing the whole picture reveal to you that your first inferences were not correct? This is why it's important to think scientifically. Until we've seen the whole picture of exactly what started and how something finishes, we can't assume that we know what's going on. Making descriptive statements, qualitative and quantitative, that show exactly what's happening rather than trying to assume we know what's happening is much more scientific thinking. Now we'll discuss how to use some simple terms called the elements of art to help us make more objective observations. If you've taken art recently, this should be familiar to you. Otherwise, enjoy these new concepts that will help us in our science class. Use the elements of art. Form, line, shape, color, texture, space, and value are all good properties to consider when making an observation of what takes place in an experiment. Use the elements of art for field sketches and for written descriptions to encourage objective consideration. For more information about the elements of art and how to use them, please see the short video on the next page, Elements of Art.